Hey guys, welcome back to Learn Python the Hard Way. In this exercise, we are going to take a look at advanced user input. In previous exercises, we wrote a number of different programs, including some text-based games that used user input to make some decisions. So for example, we had a number of different rooms and we navigated from one room to another room using some text-based commands. The problem with that was that users needed to type in precisely the specific command that was required, for example, to switch from one room to another room. So for instance, a user had to type in run, and then the user would actually run and the program would execute that command. But it was not possible that the user typed in something like run fast. We needed to precisely provide that expected input. And that of course limits us and the player, the user of the program, because the user needs to know which commands he can enter and he is kind of limited in what is accepted by our program. What we want to accomplish is to deal with some advanced user input so that, for instance, a user can type in something like this: open door, or open the door, or go through the door, punch bear, so on and so forth, so that different commands can be entered and our program should be able to handle those commands. And thereby our program should be a lot more like accepting actual English words or sentences, and that our game can deal with it and figure it out. And in order to accomplish that, we want to create a module that can handle this kind of more complex, more advanced user input. And ultimately that module will have a few classes that work together to handle user input and then convert it into something that our game can actually work with reliably. And if you just take a look at the English language, in general, a simplified version of the English language could be broken down into the following elements. First of all, we have words which are separated by spaces. Then we have sentences which are composed of these words. And of course we also have a certain set of grammar rules that structure the sentences into meaning. And of course this is a simplified version. Of course there are instances where words are not separated by spaces, but maybe by, for example, commas or a dot or an exclamation mark. But for our purposes that's a good simplification and a good starting point. So that means the best place to start is to figure out how to get words from the user and what kind of words those are. And in order to understand the inputs that the user provides, we're actually going to create a game lexicon, a dictionary that is going to include certain words that we can then work with. So for instance, we are going to have some direction words. We are going to have some verbs, stop words, nouns and numbers. And our program or module should be able to classify the words provided by the user, by the player, to actually execute commands based on that. If you take a look at the direction words, we're going to have the following direction word set. Our program, our module is going to understand: north, south, east, west, down, up, left, right, back. We're going to have some verbs that we're going to understand, like go or stop. Some stop words, which are basically filler words, like the or in. And of course a couple of nouns like door, bear, princess or cabinet. So if we take a look at nouns, of course we could run into some issues, especially if we have a more complex game that we are programming and we have a lot of different rooms that we work with. Then of course this can be kind of limiting that we only have 4 nouns here, but for starters, let's just start with those 4 nouns, and of course later on we could extend our lexicon to include additional words, additional nouns in here. So before we actually get started programming our module here to handle advanced user input, just one thing to get started: we need to be able to take some user input and break that down into individual words. So that means if a player provides some input, we need to break that input, that sentence, down into individual words. And we are going to go a very simple route here. all we're going to do is, once we get some input provided by a user, is to basically split that input based on space characters, and that's going to give us back the individual words. So if we just hop over to our command line here just for a second, and we switch over to the Python interpreter, we can, for example, say a user will provide some input. Like this. And to break this sentence down into individual words, all we're going to do is to call split on it. We already used split before, and we passed this space to it before, which is going to break this down into individual words based on spaces between those words. What we can also do, which is basically a shorthand, is just to not provide any argument here when we call split. And this is going to have the same effect because the split method here actually defaults to using the space character. So we can just call split on that, and that's going to break down our sentence into individual words. So that's just important to know as we write our program. This will be very handy. So now we know how to break a sentence down into words. Next, we basically need to figure out how we take those individual words that are part of the sentence that the user provides and classify those words. And we need to basically figure out what types they are, if they are a noun, for example, or a verb. And to do that, we are going to use a specific data structure provided by Python, which is called a tuple. And a tuple is quite similar to a list that we've already seen before in Python. The difference is that a tuple actually can't be modified. So once we create the tuple, we can, for example, not make any changes to it, and that's going to be very handy for us. And the way we create a tuple is by just putting our data inside of two parentheses separated with a comma. So for example, here we have three words. First word, verb, comma, go. The second word would be of type direction, north. And the third word would be also of type direction, west. So, and this is basically how the tuple works. So all we need to do is, if we just hop back into our Python interpreter, we just write like this, parentheses, and then in our structure here we would write the type first, and then the actual word that was provided. And then this is the tuple we are going to work with. And ultimately, of course, we can then add those tuples, those words that we created here, into a sentence, which in this case is just a list of the different tuples which are inside of that sentence. Alright, so this creates a pair, and the type is always stated first, followed by the actual word. And that lets us look at the word and do any operations on them. And this is basically what we want to get back as a result in this particular exercise to deal with the user input. And then going forward into the next exercise, we're actually going to work with the sentences themselves so we can also deal with them. So now we are ready to actually write our scanner, which is going to scan the user input and then take that raw input, split it up into individual words based on the sentence provided by the user, and then create a list of tuples based on that, where we will have the token or the type of word followed by the word. And then, of course, later on, we can use that input to infer meaning. So with that, we are going to write our program in a test-driven way. So we're going to write some unit tests, and then as we write our program, our module, we are going to execute our test cases to make sure that we actually cover all important test cases and that our code is indeed correct. So we're going to develop that in a test-driven way. Before we get started, there's just one exception, because we will get some input which is actually a number, and we need to be able to convert numbers or rather strings into numbers and do that in a proper way. And in order to deal with that, we are going to learn about exceptions. So an exception is an error that we get from some function that we may run. So we basically raise an exception when we encounter an error, and then we can handle that exception. And that's the proper way to do it, because when we don't, we can actually check if a program would work, raise an exception, and deal with that. So here we can see an example. If we just hop back into our Python interpreter, and we are trying to convert a string like hell into an integer, then of course we get an error back, because there's really no way to get any useful conversion here of that string hell into an integer. That doesn't make any sense. What we could do, of course, is this. If we have a number, actually a string that can be converted into an integer, then that would work. But if we type in anything else that cannot be converted into an integer, then we would get back an error. And the value error here that we see in our terminal basically shows us that there's an exception that the int function threw because we handed in some input, a string that is not a number, that cannot be converted to a number. So we need to cover that specific case. And in order to do that, we are going to learn about the try and except keywords here. So we can use a function which we could, for example, call to convert number, which is trying to convert some input into an integer. And if that's possible, then we are fine. It's going to return our integer here. If there's a value error, if the conversion doesn't work, because, for example, we're passing some invalid input, some string that cannot be converted to a number, then we are going to have an error. But instead of actually showing an error, we're just going to return none in this case. And this is going to be quite handy, because then our program is not going to run into an error, but we can just decide to return none and deal with this specific case here. So this try except keyword, this combination is quite useful for us. And it's important that we have this try block, and inside the try block we would always put the code that we want to actually try to convert, in this case, try to execute, and then except would be basically the error case that we want to cover. So it's just important to keep in the back of our mind. So let's get started actually writing our program, and as mentioned before, we are going to develop our program in a test-driven way. That means we are going to execute test cases as we write our code to always check if what we write actually makes sense, and that we cover all the cases which are important to cover. So what we're going to do is we're going to take a test that's actually provided to us, and we're going to write some code to make that particular test work. We're going to follow the following procedure. We are going to create one small part of the test that is provided to us. Then we make sure it runs and fails, so that we know that the test actually is executed and actually gives us an error before we implemented that capability. Then we're going to head over to our code file, to the module we are writing, and we are going to write the source code to actually make our code, the test code, pass. And we're just going to repeat that, adding to the test cases, executing those test cases, and making sure that we actually pass those tests until we cover all the test cases and implemented our functionality correctly. And when we get to step number 3, where we head over to our source code file and actually write the code to make our test pass, it's also a good idea to combine our other methods of writing code in general. So to make a skeleton function or class that we need, to write a comment inside to describe what the function, how the function works, what it does, to write the code that does what the comments describe. So once we have that outline here of the comments, then we would hop in and actually write the code. And finally, of course, we would remove any comments that just repeat the code. So we would only leave the comments in there that are actually describing why we are writing the code, not basically what the code does, because that is basically already visible in the code itself. And this approach, this method of writing code, is called pseudocode. So we would basically write down what our function does, our method does in as a comment before we actually convert it into actual code. So if we combine that test first approach with the pseudocode tactics, we have a simple process for programming. That means we write a bit of a test that fails, the unit test. Then we write the skeleton function or module or class that the test needs. We fill the skeleton function, our production code that we write, with comments in our own words, displaying how it works, which is basically the pseudocode. And then we replace the comments with the actual code to make the unit tests pass. And then of course we repeat that, going through the entire functionality until we ultimately finish writing our module for the advanced user input. All right, so what we are going to get as an input is this kind of test case here, which we are going to write in just a second. So here we have a number of different test cases. Of course, we are using nose as in the previous exercises, and we're actually going to build on top of the skeleton project structure that we created in one of the previous exercises. But if you take a quick look, we can see that we have different test cases here, for example, to test the directions, to test the verbs, to test the stop words, the nouns, and so on and so forth. And within each of those test cases, we're using again the assert equal function here, and then we are testing if some input here actually matches the expected output. And here we are working with those tuples that we just learned about before. And as we can see, we have basically test cases covering all the different types of input that we're working with, and also an error case here. So if the input that we get provided doesn't match any of the types that we have, then we can also cover that error case. But instead of just typing the entire test code out here, what we're going to do is we are just going to first create our skeleton project code, just like we did in the previous exercise, and then step by step we're actually going to fill in the test cases, then test them, execute them, and make sure that it actually works, because we're going to, of course, write our code to implement that capability in parallel. So let's get started with that, and let's hop over to our terminal. What I'm going to do is I'm going to copy over the code that we wrote in one of the previous exercises, our skeleton code. So we are going to copy recursively our skeleton code over to, let's call it just exercise 48. And then we can hop over to the exercise 48 folder and just let's take a look what's inside. And of course, this is basically the skeleton structure that we created before. So we have the name placeholder directory here, for example, our setup Python code, and our tests folder here. And then of course we can go ahead and just rename that. So I'm going to call mv for move on name to rename that. And let's rename it, for example, to exercise 48. So we can switch into exercise 48. That looks okay. Let's get out of that again. We can open, or we can switch over to our tests folder. And if we take a look at that, we can see we have a name underscore tests.py. So we could move that again and rename that to, let's call it lexicon underscore tests.py. So that is renamed. And then let's open lexicon. Let's open it up actually, because this is going to be our Python file that we are going to use to write out the test cases to test our code here. So this is our structure here, and instead of importing name here, we need of course to change that to exercise 48. I'm already going to, well, let's leave it in here for now. This is our template test code, which we are going to replace in just a second. The other thing we need to do if we hop back in here is to open our setup Python file, which is basically the Python file we are using to set up our structure here for our skeleton project. And here we can, of course, change our configuration. So let's call the description here advanced user input. And we also need to rename the packages here to exercise 48. Let's save that. And let's go back here. And what I'm going to do right now, I'm going to run nose tests just to see if that works. So we are running one test here. And if we just take a look at that, that's of course our template code here. So this is just a placeholder. We could actually remove that now because we don't need it anymore. All right, so what we need to do, so we have renamed the test cases folder here, and then we need to also create the lexicon.py file, which we're going to use to actually write our code. So if you take a look at that, we need to actually create that lexicon.py file, which is going to be an empty file to start out with, but then of course we are going to add our code there, and in parallel to writing our tests we're going to do that. So let's just save that for now, and then we're going to work with this. All right, so next we're going to follow the procedure to basically write our test cases. First of all, we are going to write the import statement at the top of the test case file. And then we're going to create an empty version of the first test case called test directions and make sure that it runs. And of course it will fail when we execute that because we don't have that production code yet. So let's do that. Let's just take a look at the top of our test file here. And what we need to do first of all is to say that from nose, actually I'm in the wrong file here. So from nose.tools import everything, and then we say here from exercise 48 import lexicon. That's basically the first step. And then we write the test case test directions, and we can just leave it empty for now, so we can just write in parse. We can then run nose tests again to see if that still works. And then we run into an error here because it says we cannot import that. Let me just double check that real quick. Oh, we didn't save that file. I think that's an issue here. Let me just switch over to exercise 48 here, and let's just create that file called lexicon.py. All right, and now that should ideally work. So let's run nose tests again. Yeah, so that was the issue. I just didn't save that file here. Let me just close it for now. All right, so we have that one test here that runs, and we have pass here, so it basically executed that test case. So now we can start and actually insert the first test case, the actual test case here. So we are going to write assert equal lexicon.scan north, and that should be equal to the tuple direction north, like this. Let's just take a look again at the structure here. So we wrote the import statement at the top. We created an empty version of the first test case and made sure that it runs. Then what we're doing right now, we write the first line of the test direction test case, and then we need to make sure that it actually fails. So let's run nose tests again, just to execute the test case here. And now we see the test case, of course, failed because we don't have any code yet in our actual program that we are writing. So now we had to go to the lexicon.py file and create an empty scan function. So let's do that. So let's switch over to lexicon.py and open that folder here. Oh, excuse me, that Python file. And now we can go ahead and actually write that empty scan function. So we can just write it like this. Define a new function, scan, and it should be empty for now. And now we need to make sure that we can run our test again. And of course, the test will still fail, but we should make sure that it at least basically doesn't give us an error about that. And now what we get back is that scan takes 0 positional arguments, but 1 was given. So the reason for that is, of course, because if we take a look at our test case here, we can see that lexicon.scan actually takes 1 argument here, and we didn't provide that in our Python file here. So let's just change that. We can call that, for example, input, and then we can run that again. And now we shouldn't get that particular error, but now we get back that there is an assertion error, so none is not equal to what is expected in our test case, which is direction north. All right, so that is actually correct, even though the test, of course, fails at the current time. So now we should fill in the pseudocode in how scan should work to make test directions pass. So to do that, let's just take another look at our test case here. So we want to make sure that when we pass in north, what we expect is to get back direction north. And we could start really simply. We can say we want to basically split the input based on the spaces provided. And then let's start with a very easy case, return a tuple called direction, and then followed by the input here, like this. All right, so that of course doesn't cover all future cases, but it can be a starting point here. So that would be our pseudocode. And now we need to write out our code to actually make our test pass. So what we can do is we can say we want to take our input and split this, and we can store that back into a variable. For example, we could call it words. And for now we only have a single word, because we just take that single input north. But later on, if we have multiple fields as an input, then we can iterate over those different words. So we could write for word in words. We want to iterate over each individual word, and then we could, for example, add that to a list and then return it back. For now, we can just start very simply and just say we want to return a tuple called direction and then the actual word. So we could even make this simpler and take out the first row and just return back the input. And that what should happen now is if we take the input here, which is north, what should happen here is that it returns the tuple direction and then comma north, and it should cover that specific test case here. So if we execute our code, let's see if that actually passes or if we made a mistake here. So actually it failed. And the reason is we have an assertion error here. Oh yeah, we expect actually to get back not just a tuple, but actually an array of tuples. So one thing we could do just to make this particular test case pass is this here, to put that into quotation marks to actually return a list of tuples. All right, and now we make our test pass here. Of course, that is very specific to that test case we're taking a look at. Going forward, we are going to write some code that is more general, so we cover those test cases. But that's basically how we refine our code step by step to get to the point that we can actually work with it. So now we would go ahead and take the rest of the test case here. We have, for example, here result that has now an input of 3 different arguments, 3 different words, and what we expect back is this particular output here, direction north, direction south, and direction east, because all 3 values that all 3 words that we provided here are of type direction. And we can now go ahead and basically take this, and I'm just going to save some time, actually just copy it over into our test case. And then we can insert that in here. And of course, now if we go ahead and we execute our test case again, then of course this will fail because the first test case here, we basically hard-coded the return to that. So we can see here it is expecting some other output. So that's why our test case here failed. And now, of course, we would go back and refine our code here to actually cover those cases. And one thing that I did ahead of time is actually to write out some code on how that could be solved. So if I just hop onto a different file here, we can see one example solution of how we would resolve that. It's just important to basically switch back and forth between the test cases that we are writing and the specific output. So here are actually 2 different solutions to those different test cases. And if you just take a look at that, if we compare it here to the test cases, we have, first of all, of course, our assert equal that north, if we type that in, should give us back direction north. And then if we have an input of 3 different words, we want that split up into tuples, which are part of a list. So one way how we could solve that is that if we think back to the list of different types of words here, at the top we have direction words, we have verbs, we have stop words, nouns, and numbers. And we could basically create a list for each of those and then basically store those particular words in those kind of lists. For example, for directions, we have north, south, east, and so on and so forth. And then inside of our scan function here, we could take the input that we get from the user, split this up, and store that in words. And then we can go ahead and we iterate over each word in our words list. And if that word is in that directions list, for example, then we can assign the direction type to it, basically. If instead it's in the verbs list, we would do that. And then at the end of that, we basically append to our sentence list, which is an empty list here at the beginning, we basically append the operation that we identified, the type, and then also the word here. And at the end, of course, we return that sentence here. And that would make our test case pass. And then taking a look at the test cases again, we would continue with the next case. So if we just go back here, we are testing verbs. So let's just do this for now actually. If we just comment out, for example, here, verbs, stop words, and nouns. And the specific branches here as well. If we now run our tests, we will see that the tests will actually fail. I'm actually in the wrong folder here. Because, here we can see that we are actually failing some tests, and in particular, the test error case, for example, which is one of the later cases, fails because we don't cover, for example, those error cases here. We need to add step by step the different other types, for example, verbs, stop words, and nouns to it. And then as we do that, we can execute the code again, or rather execute our tests. And then ultimately, of course, our test should pass when we covered all the different cases. So here we have a total of 6 different test cases, and they can be covered here. And just to take a look at one specific part here, if we take a look at test numbers here, which is one of the test cases that we're dealing with, we need to make sure that we, of course, can convert the actual input into a number if that's allowed. So the way we solve that here is to use convert number, which is a specific method that we wrote, or a specific function that we wrote here at the bottom. So convert number takes an input and it tries to convert that into an integer. If that works, then it will return that integer. If that doesn't work, then it will raise an exception here, an error, and return none instead. So this is how we are testing for direction, verbs, stop words, and nouns. In terms of the numbers here, what we do is we are testing if we can convert that to a number, and if that indeed works, then we are assigning number as the operation here, and of course set word to whatever the output is or the return value is of calling convert number, and here at the bottom we would append that to our sentence as well. And ultimately we have the case that we have some error cases here. So for instance, we want to assert that if we scan for this particular, what is not really a word, which is not part of any of our predefined types, then we should classify that as an error. So the way it's solved here is that we at the bottom have an else statement. So if it is not part of any of the other types, and if it also is not a number, then we would classify it as an error and return that back. That's how we can solve that. And that's of course just one way how we can solve or implement our advanced user capability. Another possible solution is the following, which is not using lists as we are doing up here. Instead, what we do is we are working with a dictionary, which might be more suitable in this case here. So we are basically creating or working with a lexicon, a dictionary here. So here, instead of having 4 or 5 different types of lists of different types, we are instead using a dictionary, which is taking each of those different words that we classified and is basically assigning as a value to that word, which is here as a key, as a specific type. So if we have type north or input north, that should be of type direction. If instead we have input go, that should be classified as a verb. So it's a little bit more, a little longer here in terms of what we need to include in our lexicon. In terms of the overall structure, we have a little bit more extra code basically, because we always type direction. In this case, for example, we're repeating that a little bit, which was not the case in the way we took with the different lists. but it's quite easy to extend that lexicon. We just have one dictionary to take a look at, and we can just append additional words, for example, that we want to work with. And then what we do here is we have an empty list called sentence, and we would then take the input that we get from the user, split it again to get our words, we iterate over those words, and then we can basically check if it is a number or not. And if it is, we are going to append it to the sentence as a tuple here with type number and then with a specific word, which is a number in this case. If that's not a number, then we are going to instead take a look at the keys. This is a specific method that we can call on dictionaries, which gives us back basically all the keys of our dictionary. And if the word is in our key here, then we are going to append it with the particular value. So here we're calling lexicon, which is a dictionary here, and we're passing the word as a key to it. So if we, for example, have an input of west, we would get back direction. That would be the first entry here of our tuple. And then, of course, we have the word. And else, so if that word is not included in our lexicon here as a key, then instead we get back error. And that basically means it's not part of our lexicon, of our dictionary. So instead we are giving back an error. And ultimately, of course, we return the sentence. So this is an alternative approach we could basically take to solve that and implement this. But importantly, we would go step by step to write out the test case, execute the test case, make it fail first of all, then write the code to actually make the test pass, to check that the test pass, and then continue with the next test case step by step. And as long as we keep this procedure and follow it, then we can successfully turn a large problem into basically smaller solvable problems in our test cases, and step by step implement parts of the functionality until ultimately we implemented the whole thing, the whole program that we are working towards. So let's take a look at the study drill section here. The first one is to improve the unit tests to make sure that we test more of the lexicon. So basically, if we just take another look at our test cases, let's just switch over to our tests. And let's open this already completed test cases program. These are the different test cases that we have, but we can see that we are only testing some of our lexicons. So for example, here we're testing north as one of the directions, and then here north, south, and east. But if we hop over to our lexicon file, we have, for example, also down and up as directions. That is not yet included in our lexicon here. So what we can do in our test cases, so what we can do here is just to add an additional test case. So we could, for example, say we assert the following to be equal if we call lexicon.scan and we call up on it. Then we should get back the following. It's of type direction, and of course it's also up. Let's just take one more look at it. Yes, up is indeed in our lexicon, so that should work. Let's run our test one more time, and of course we always have to head back to our root in our directory here and call nose tests. And now we get back that all tests have passed successfully, so that has been covered. And just to test the opposite, if we basically go ahead now and we say that we are removing up from our lexicon here, so let's just comment that out for a second, then our test should actually fail, because now we are testing for that, and that's always a sanity check that it actually fails here. Yeah. So here we basically get an unexpected output back, and now actually it classifies it as an error because it's not part of our lexicon. We commented it out here. So let's just undo that real quick And let's run the test again. And now it should work correctly. So we are testing more of our lexicon here. We get back status OK, so it passed the test. So that's a good way to test for it. And of course we could do that for additional parts of our other test cases as well, just in the same way to test more of our functionality. Of course, the more we test, the more sure we can be that our code is indeed correct and that all the relevant cases are tested. So the next study dual question here is to add to the lexicon, and then update the unit test. All right, so what we want to do is we want to head to our production code here, and we could, for example, add to our nouns. We have bear, princess, and cabinet right now. If we are thinking about the different rooms of our game that we want to work with, maybe we want to have an additional room here. Maybe let's just call it space, which should also be a noun. And actually, let's do it the other way around. I'm just going to not add that for now, but let's start by writing the test. What we actually need to do is we need to add it to nouns here at the bottom. So let's go here and add space. And now what we expect to get back is a noun space like this. Let's save it. And now let's make the test fail one more time because we didn't add it yet. Yep, so we get back error space instead of noun space. Let's now head over here and add space as a noun. Let's save that again and run the code. And now if we didn't make an error, then it should pass. Yeah, so this is how we could add to our lexicon while adding test cases. So we cover all of that and we test our code while we do that. So let's make sure that our scanner actually handles user input in any capitalization and case. Update the test to make sure this actually works. So far what we did is, if you take a look at the tests, we always passed lowercase input basically to it. But what we want to make sure is that we can do, for instance, the following. If we write north, for example, and we capitalize the first letter here, and of course then we also need to adjust what we expect back, that should also work. So it shouldn't matter if I capitalize a word or I wrote a word, for example, in all caps. That should still give me back the correct input here, or the correct result. And so what we could also do is, if we take east, for example, here, and we type this in all caps, then that should still work. And if we take a look at our test cases right now, if we have that capitalized input or the uppercase input, we get actually an error back because our test cases, or our code rather, can't yet handle any other case than lowercase. So we need to adjust that in our code. So here we see what we get back here is when we type in north and we capitalize it, it classifies it as an error because it doesn't know that word here. And of course, one way to solve that would be to basically do a lot of typing and type out, for example, this in addition to the lowercase north, and but that of course would end up being a lot of work, so we would have to cover all those different cases. What we can do instead is we can basically take our code here and make sure that we convert the input to a lowercase and then cover that. So for instance, we have here the case that our word is a number. If instead it's a word, what we can do is, here we are checking in this line if the words that we have is actually inside of the keys list that we get from our dictionary. And this is basically where we fail our test case, because north capitalized, for example, or in all caps, is actually not in this list. What we can do instead is we can call a method called lower, and that would take our input and convert it to lowercase, and then check if that is now keys list. And that should actually solve the issue for us. Let's just briefly hop on over to the Python interpreter. And if we take north like this and call lower on it, we can see that we get back north in all lowercase letters. And also if we take the other case, north like this, and we call lower on it, it will also give us back north as in all lowercase letters. So that should actually cover those cases that we can get our input in any lowercase or uppercase form and deal with it. So let's see if that makes our tests pass. So let's run those tests again, and before, of course, our tests failed. We still get an error back, so let's take a look at that. So we get a key error. Oh yeah, so what we do here in the next line is we take the word and we check for the key in our lexicon. And of course we need to make sure that we also are calling the lower function here, because of course we need to check for the actual key that is inside of our dictionary, and if we pass in north with a capitalized letter, then of course it can't find that value. So let's run that one more time and let's see if that solves the issue. Yeah, now we get back that our tests run successfully, and so we know that we now can also deal with all uppercase or capitalized input, for example. So it's case insensitive what the user provides. The next exercise here too is to find another way to convert the number. So what we did before, if we take a look up here, is we used this particular function, convert number, and that's what we looked at over here when we worked with it. And actually in the second solution here, I already cheated a bit and added another way in here. So what we can do is we can call isDigit on it, so we can check if a number is actually a digit or not. And if it is, then we can convert it into an integer. So that would be an alternative way. This way we can use an existing function inside of the Python library basically, and the Python standard library, and we don't have to write a separate function for it. So that can save us some time, and of course in general it's a good idea if that's already provided by Python, which is the case for operations that are frequently used. Then we should use that rather than write or re-implement a solution to a problem that has already been solved. And finally, the solution that the author wrote is 37 lines long. Is ours longer or shorter? So if we take a look at the top solution here, those are actually 35 lines, including the convert number function here. Without that, it would be 28 lines. And of course, we could remove a line here, then it would also be 27 lines long. If we take a look at the other solution here, that's actually 38 lines long. So, and of course, we could have written our dictionary here to be more in one line to shorten it, but we want to have it as readable as possible. So there are, of course, a number of different solutions. That's by no means the only solution or the best solution even. The important thing is that we make our tests pass and that we understand our code and it's written in a clear structure. Let's take a look at some common student questions. So the first question is, why do I keep getting import errors? And import errors are usually caused by four things. Either we didn't create the init Python file in a directory that has a module in it, so we made a mistake in the setup. Or as a second case, we are in the wrong directory. So for example, that we navigated down to maybe the tests folder, or we are in a completely unrelated directory. Or we are importing the wrong module because we spelled it wrong, or our Python path isn't set to the correct one, so that modules are not loaded from the correct directory. So we also need to make sure that our setup is correct. So what's the difference between try except, which just as a reminder, we used above here to check for the conversion of a number, if we could convert a string into a number or if that wasn't possible, and if else. So the try except construct is only used for handling exceptions that modules can throw. It should never be used as an alternative to if else. So these are separate things. Try except would only be used for handling error cases, and yeah, if you want to basically branch or check for conditions, then we would use, of course, if else. And finally, is there a way to keep the game running while the user is waiting to type? So I'm assuming that you want to have a monster attack users if they don't react quickly enough. It is possible, but it involves modules and techniques that are outside of this book's domain. So we can actually write a game that would stop running or would be running while the user is typing input, but that's a little bit more advanced, and we won't need it for the type of games that we're going to program as part in this book, in these exercises that we're working with. So that's it for exercise 48. For now, we implemented a way to deal with user input and classify it and assign it to tuples, which in turn will be assigned to a list. And in the next exercise, we're actually going to continue with that and work on working with sentences to actually handle that and use it for our game. So see you guys next time in exercise 49.